let's start with Rutherford's model of an atom. We'll talk about the experimental setup, observation, and a few conclusions, and finally the limitations of this model. So the very first experimental setup was something like this. In the Rutherford model, what happened was they used a gold foil, a very thin gold foil, and alpha particles were shooted towards the gold foil. Behind our gold foil is a screen present, which is again coated with a fluorescent material of zinc sulfide. Let's see some observation what we were seeing during the experiment. The very first one, your alpha particles were projected, and how these alpha particles were made? They were made by using a radioactive material. Radium was used, and when the alpha particles were coming out of radium, we were using a electric and magnetic field so that they can travel directly towards the gold foil. See, alpha particles are nothing but they are the nucleus of helium atom. That is He2 positive. Let's see the next observation. Most of the alpha particles were not deflected and passed directly through the gold foil. The next observation was that very few of these alpha particles were deflected at a very small angle, and the last observation was that only 1 out of 20,000 are deflected at very large angles. These were the few observations about the Rutherford model of an atom or the experiment. Now let's see what were the conclusions made out from these observations. The very first observation was that from the deflection of alpha particles, that almost your atom is empty, and the major mass, or your almost 99.99% of mass of your atom resides in the center, which is called as the nucleus. The next conclusion was that the negatively charged electrons are revolving around the nucleus. And how they were revolving? They were revolving at a very high speed, like our planets revolve around the sun. That's how the Rutherford model of an atom was making its image. The next is that why were these electrons are revolving? They have, obviously your nucleus is a positively charged body, while your electrons are negatively charged particles. So obviously there is electrostatic force of attraction between them. That is why they were revolving around it. But why they are not falling into it is that because electrostatic force of attraction were equal. One more major conclusion was that the number of protons and number of electrons has to be equal so that your overall atom is neutral. Rutherford jumped to the conclusion that electrons revolve around the nucleus, but he never explained us that how these electrons are revolving, how far they are revolving from the nucleus, and why they are not falling into the nucleus itself. The next conclusion is that electrostatic force of attraction is equals to a centripetal force. A centripetal force is a force which is acting outward. So let's say this is an atom. In the center we have nucleus and electron is somewhere over here. This has a electrostatic force of attraction between them. Also at the same time, it is having centripetal force which is trying to pull out the electron from its orbit, and it is applied at a 90-degree angle. So that is how the electron was revolving in the nucleus. Let's see some limitations of Rutherford model of an atom. The very first limitation was that it was not able to explain the Maxwell theory. According to Maxwell, if any charged particle is traveling through the space, it always loses some energy. Same is with the electron. Electron is a charged particle and is revolving around the nucleus, so it should go spiral down and went into the nucleus. But this is not the case. We see electrons are continuously revolving around the nucleus. So he was not able to explain it, why it is not going inside the nucleus. So the next limitation was that he could not explain the discrete spectrum of the atom. Every atom has a discrete spectrum. We will be studying this thoroughly in the Bohr's model of an atom. So these were the few things that Rutherford's model of an atom was not able to explain us. That is why the Bohr model came into the reality. So we'll talk about the Bohr model of an atom in the next part. But one more last thing which helped Bohr, or differentiate the Bohr model of an atom from the Rutherford model of an atom, is that Rutherford was never able to explain the arrangement of electron. He was not able to explain the distance between a nucleus and a electron, but Bohr did. These were the some key differences between Rutherford model of an atom and Bohr's model of an atom, which we will be discussing in the next part.